Good day. This is Mr. Roche speaking, and welcome to Mr. Roche's Flipped Class Math 10 Low Budget, Low Tech videos. In this series, we'll be investigating right triangle trigonometry. This will be separated into 4 parts. Part 1, we'll be finding out what trigonometry is, how we name the sides in a right triangle, as well as what the 3 primary trig ratios are. In part 2, we'll be able to find out how to find an angle using right triangle trigonometry ratios. Part 3, we'll be finding a side using right triangle trig ratios. And finally, part 4, we'll investigate applications and problem solving using right triangle trig ratios. First, for part 1. The word trigonometry literally means the measures in a triangle. Trigonometry is used to find missing measures in triangles when other strategies like Pythagoras, a squared plus b squared is c squared, or c squared minus b squared is a squared, and other strategies like triangle equals 1a and so forth. Trigonometry can be used in conjunction with those or instead of those in order to find missing parts of a right triangle. Trigonometry can also be used for non-right triangles, but for grade 10, we'll only be studying right triangles. Grade 11, we'll be doing non-right triangles. In order to use our trigonometry, we have to first name the sides of a right triangle. We already know that the long side in a right triangle is called the hypotenuse. We called it that when we used Pythagoras. Hypotenuse is always the longest side in a right triangle, and it's always across from the right angle itself. So that's the hypotenuse. The other 2 sides, when we use Pythagoras, we call legs. For now, we'll need to give those more precise names, specifically the opposite side and the adjacent side. The thing is, those can be the other way around. What we have to do is we have to involve an angle in the question. In this particular question, I've drawn an arc here to indicate that C is involved in the question. Perhaps we'll be asked to find C, or perhaps they'll give us C in order to find a side. Either way, if C is involved, I'll call that angle my reference angle because I can refer to it in order to name these 2 sides. You'll notice the opposite side is across from angle C. Like the person who lives opposite me on my street is the person who lives across from me on my street. Conversely, the word adjacent means alongside or beside the angle C. The person who lives adjacent to me on my street is my next door neighbor. Okay, if I was to switch this reference angle to angle A, the hypotenuse would still be this long side. However, this would become the opposite because it would be across from A, and this would be the adjacent side because it's alongside A. If we were given both of these angles, we simply choose which one we want to use as a reference angle and then name the sides accordingly. On your fancy scientific calculators or your graphing calculators, you may have noticed some buttons on there that have the word sin, or S-I-N, cos, C-O-S, or tan, T-A-N, and wondered what those were for. Well, we'll be using those from now on. The 3 primary trig ratios is what this part is about. The names sine, cosine, and tangent, those will abbreviate to sin, cos, and tan. And what those words mean are, they're simply names given to ratios of 2 sides of a right triangle. Simple as that. Okay, if we were talking about the ratio of these 2 sides, or these 2 sides, or these 2 sides, they would have different names. Before we can name the ratios, we have to be able to name the sides. So, first I need a reference angle. So if this is my reference angle, angle C, we can now name these sides. This is the longest side. This is the side opposite angle C, so it's the opposite. And this side is adjacent to C, so it's the adjacent. Excuse me. Okay, now you'll see this fancy looking acronym up here. It's called SOHCAHTOA. I think everyone in the English-speaking language uses SOHCAHTOA when they use right triangle trig. It's an easy acronym, just like BEDMAS helps us remind us of the order of operations. SOHCAHTOA will help us to remember the three basic trig ratios for right triangles. The S stands for sine, and it means the ratio of the opposite compared to the hypotenuse. Cosine is adjacent to the hypotenuse, and tangent is opposite to the adjacent. So, whenever we want to find a trigonometric ratio, we just look at this reference angle, see which two sides we want involved. So perhaps it's opposite and hypotenuse. Opposite and hypotenuse is the sine ratio. So the sine ratio literally is this side to this side. The cosine ratio is the adjacent to hypotenuse, this one to this one, and the tangent is opposite to adjacent, this one to this one. Okay, we learned back in previous grades that ratios can be written with a colon, and they're expressed with the word to, like something to something. So, for example, sine is opposite to hypotenuse. We also remember that ratios we could write as something to something this way. When we use trigonometry now to solve problems, often we even divide the top by arm, sort of like we do with a fraction, in order to change the ratio to a decimal form, and that way it's easier to enter into our calculators or use a trigonometry table. All right? So, let's see what we have here. If I was asked for the tangent ratio of C, tangent ratio of angle C, that means I want to compare the opposite to the adjacent. Hence, TOA, tangent is opposite to adjacent. So, in this case, if I was just using letters to illustrate this, I would say I'm comparing the length of AB to the adjacent that's BC. That's it. That's all I can do right now. I don't know those lengths, so I can't figure out any angles yet. Whereas the sine of C is, sine is opposite over hypotenuse. So here's sine, here's opposite, here's hypotenuse. So it'd be AB to AC. AB to AC. And finally, the cosine of angle C is equal to, cosine is adjacent over hypotenuse, so that is BC compared to AC. Okay, pretty simple so far. Now let's start putting some numbers into these ratios and actually finding out a bit more. Let's see. I'm just going to make a little bit of room here. Okay, we know that two sides of a right triangle, we can calculate the third using Pythagoras. In this case, we're looking for the long side, so we use a squared plus b squared is c squared. I'll just speed through this because you already know this. So a squared plus b squared is c squared. That would be 144 plus 25 is 169, square root of which is 13. So this side would be 13 centimeters. All right, if I wanted to find the ratios in here, I need a reference angle. Let's say I use this angle here. Okay, and I can call that using, if I name this triangle M and P, I could call this angle P, or I could put a symbol in here like theta or something like that. So, let's start with sine this time. The sine of this angle, sine of theta, is equal to opposite over hypotenuse. Opposite over hypotenuse. So that would be 12 to 13. I could also change that to a decimal by going 12 divided by 13. But for now, I'll just leave it as a fraction. The cosine of theta is adjacent over hypotenuse, so 5 over 13. And finally, the tangent of theta is equal to opposite over adjacent, 12 to 5. If those were reducible, I could reduce them, and of course I could always also change them into decimal numbers. If I change them to decimal numbers, I like to go to 4 decimal places, okay? And that way it doesn't matter if I go to 4 places or 10 places, I'll get the same answer as far as finding an angle later on. If I go less than 4 places, that's not accurate enough because it might, I could actually be off by 1/10 of a degree or something like Okay, that's it for now. This concludes part one. In part two, I'll actually be able to show you how to find an angle using these particular trig ratios. Thank you.